Assalamualaikum. We are going to discuss AC and DC plasma. Assalamualaikum. We are going to present about what is AC and DC plasma, how plasma is generated, and what are their application. Firstly, plasma, often referred to as the food-state matter, is a highly ionized gas consisting of ion, electron, and neutral particles. It is generated when sufficient energy is provided to a gas to ionize its atom or molecule, stripping electrons and creating a mixture of charged particles. Plasma has unique properties distinct from solid, liquid, and gas, including high electrical conductivity, responsiveness to magnetic field, and the ability to generate electromagnetic radiation. Plasma can be generated and sustained using different methods, including alternating current and direct current power supplies. Each method produces plasma with different characteristics and it suits to different applications. Plasma generation method, AC and DC. Both AC and DC plasma generation method has their own advantage and limitation. DC plasma are simpler and provide steady state condition, making them ideal for certain industrial applications. AC plasma, particularly at high frequency, offer more flexibility and are critical advanced material processing technology. The choice between AC and DC plasma generation depends on the specific requirement of the application, such as the desired plasma properties, stability, and system complexity.
So AC plasma system. First, plasma lighting. How plasma work? Gas discharge and alternating current AC in applied to an electrode placed in a bulb or closed tube containing a gas at low pressure. Plasma generation and AC voltage. Ion the gas, causing the electron to become excited and jump to a high energy level. When the electron return to a lower energy level, they limit photon as the release energy. Characteristic and advantage of AC plasma lighting. High intensity. AC plasma lamp can produce very bright light source, often surpassing traditional incandescent, fluorescent, and even some LED lamp in terms of luminous efficiency. So efficiency, they are highly efficient in converting electrical energy into light energy, making them suitable for application requiring high brightness and minimal energy consumption. Longevity. AC plasma lamp can have long operational lifetime, often exceeding tradition but due to the absence of the electrode seen in incandescent and fluorescent lamp. Instant start. Unlike some other type of gas discharge lamp, AC plasma lamp typically have instant start capability, reaching full brightness immediately upon activation. So the second, plasma heating. How plasma work? Plasma generation, a low pressure gas, typically a noble gas like argon, is introduced into a vacuum chamber. A DC voltage is applied between two electrodes, usually a grounded anode and a target material cathode. Ionization. The DC electric field ions the gas molecule, creating a plasma of positively charged ion, electron, and neutral atom. So, advantage of DC plasma heating. High precision. allow for precise control over etching, depth and profile critical for microelectronic and nanotechnology application. Selective etching can selectively remove specific matter while leaving other impaired, enabling complex multi-layered device fabrication. Subscalability suitable for large-scale manufacturing due to the efficiency and scalability in etching process. Process flexibility can be adapted for different materials and geometries, making it versatile across various industries, from electronic to biomedical device.
Next is second DC application is plasma ARC welding, and this is how it works. First is electrode and gas ionization. In plasma ARC welding, a direct current, and we call it DC, power source is used to create a plasma ARC. Typically, a non-consumable tungsten electrode is used. The DC current passes through the electrode, which is surrounded by a shielding gas such as argon and helium. And then second, plasma formation. As the DC current flow through the electrode, it ionizes the shielding gas, creating a plasma ARC. The ARC generates extremely high temperature, reaching up to 200 degrees Celsius. And third is welding process. The intense heat from the plasma ARC melt the base metal being welded. The molten metal pulls together, and upon solidification from a strong weld joint. And the lastly is control the precision. DC power allow for precise control over the welding ARC. Parameters such as current intensity, ARC length, and shielding gas flow rate can be adjusted to optimize weld quality and process efficiency. And this is advantages. Firstly, stable ARC. DC provide a stable ARC with constant heat inputs, essential for achieving high quality welds. And second is high energy density. The concentrate energy of the plasma ARC enable deep penetration and rapid welding speeds. And lastly is controlled process. Operator can finely tune welding parameter to meet specific welding requirements, ensuring precision and repeatability in production. This is a second AC application. In this is induction heating for plasma processing. And this is how it works. First is AC magnetic field generation. In induction heating for plasma processing, and alternating current is, we call it AC, power source generate a fluctuating magnetic field. And second is inductive heating. This magnetic field induce the current within a conductive material placed within or near the AC coil. The material could be the workpiece itself or the subceptor material designed to transfer heat to another material. And third is heat generation. The resistance of the material to the ED current generate heat due to Joule heating, rapidly raising the material temperature. And lastly is the plasma generation. The intense heat cause the material to ionize and emit electron, creating a plasma discharge. This plasma can interact with gas introduced into the chamber, allowing for various plasma processing application. Advantages: efficient heating, AC induction heating efficiency heat conductive material to high temperature due to the rapid and uniform heat generation. And second is uniform heating, provide even heating across the material surface, critical for constant plasma generation and processing. And lastly is versatility. AC induction heating can be applied to the wide range of material and geometry, making it stable to dissolve plasma processing application.
AC voltage application. An AC voltage is applied to the electrodes, creating an oscillating electric field across each cell. To UV radiation, the ionized gas emits UV photons as the electrons recombine with ion. 3 pixel activation. Each pixel in PDP consists of 3 subcells, one for each primary color, red, green, blue. By controlling the intensity of light from these subcells, a wide range of color can be produced. Last image display. The display panel is divided into millions of these pixels, and by precisely controlling which cells are activated and the intensity of their light, a full color image is created. Next is advantages. Consistent picture quality. PDP maintain consistent picture quality and color accuracy across a wide viewing angle, making them ideal for large rooms where viewers may sit at various angles. Motion clarity. Plasma display have a very fast responsive time, reducing motion blur and providing clear image during fast-moving scenes, making them suitable for watching sport and action movies. Longevity. Plasma display are durable and can have a long lifespan. Then the technology is resistant to physical impacts because of the glass screen used in PDPs. Even lightning. The uniform distribution of plasma cells across the screen ensure even brightness without the risk of black light bleeding, a common issue in some LCD displays. Next is DC application, plasma cutting. One electric arc initiation. When the DC power supply is turned on, an electric arc is established between the cathode and the anode workpiece. 2. Plasma jet. The high velocity plasma jet is expelled through the constricting nozzle, focusing the energy onto the small area of the workpiece. 3. Electric arc initiation. When the DC power supply is turned on, an electric arc is established between the cathode and the anode. Next is advantageous plasma cutting. 1. Efficiency. DC plasma cutting is significantly faster than traditional cutting methods like oxy-fuel cutting. This increases speed, boosts productivity, and reduces cutting times. 2. Clean edge. The high temperature and precision of the plasma jet produce clean edge with minimal slack or dross, reducing the need for secondary finishing process. 3. Material variety. DC plasma cutting can be used on the wide range of conductive material, including stainless steel, aluminium, copper, brass, and other non-ferrous metal. Last, lower operating cost. Plasma cutting generally has lower operation cost compared to the other cutting method due to its speed and efficiency.
Both AC and DC plasma are pivotal in modern technology, each which is unique advantage and application. DC plasma, which its stable and controllable nature, is preferred to precision tasks in material processing and analytical technique. AC plasma, which its versatile and dynamic characteristics, excel in applications like surface treatment, display, and biomedical use. The choice between AC and DC plasma depends on the specific requirement of the application, such as the need for stability, control, frequency of the electric field, and the type of interaction desired with material. Understanding the fundamental difference between AC and DC plasma generation help in optimizing their use across diverse fields.